So now we're going to talk about solution stoichiometry. And I told you stoichiometry was going to rear its ugly head over and over again. But the key to solution stoichiometry is it's just like every other stoichiometry. You know, when we did regular stoichiometry, we did gram to gram conversions. When we did gas stoichiometry, we did conversions, but we threw the PV equals nRT in there. Well, now because we're talking about solutions, we're still going to do stoichiometry, but now instead of PV equals nRT, now we're going to throw in molarities. So let's look at this problem. It says, what volume in milliliters of 0.20 molar Ki is required to precipitate all of the lead as PbI2 from 15 milliliters of 0.25 molar lead nitrate? Now here's the thing about these problems. There's really only one way to do them. So it's not like the other ones where you've had a lot of different options or you can how to compare things. There's only one piece of information that's given in this problem, and they tell us that we have 15 milliliters of this solution, which is right here. Okay? Well, in order to do stoichiometry, the same rules apply. I need to do a mole conversion. I need to use my balanced chemical reaction. And because this is solutions, I'm going to have to do something with molarity. Well, since they give us volume and molarity, let's find moles. And we always start by writing down our formula. So they tell us we have a 0.25 molar solution . Go away. 0.25 molar solution, and we have 0.015 liters of it. Go away. Okay, so this is going to help me solve moles. So I'm going to cross multiply and solve. Pull out a calculator. 0.25 times 0.015 is 0.00375. Okay, now what is this moles of? This is moles of that lead nitrate. Okay, now what good does that do me? Well, it doesn't do me a lot of good yet. But I can use it because I have a balanced chemical equation, and I've done molarity. Because I have a balanced chemical equation, I can make a comparison of the lead nitrate to the potassium iodide that I'm looking for in this problem. So let me use my mole ratio to find moles of potassium iodide. So I look at my chemical reaction, and I see that 1 lead nitrate is equal to 2 Ki. Now, I don't want to go to grams. Why don't I want to go to grams? Because the question says, what is the volume in milliliters? So I'm going to go right back into molarities. So I'm going to find the number of moles, but now I'm going to find the moles of Ki. Well, that's just twice 0.00375. Of course, I'm going to double check my numbers. Oops. Times 2, just easier, 0.0075 moles. Okay, so plug in what I know. 20 molarities, 0.0075, and I solve for my liters. Cross multiply and divide. So I'm going to have 0.0075 divided by 0.20 is 0.0375. And of course that's liters of Ki, but the problem doesn't ask for liters of Ki. The problem specifically says in milliliters. So I divide by 1,000 and I get 37.5. I'm sorry, not divide by 1,000. I multiply by 1,000 and I get 37.5 milliliters. Okay, now I did my balanced chemical reaction. Now in this problem, I didn't do the mole conversion. Why didn't I do a mole conversion? Because the problem never asked for it. Now sometimes they will say how many grams of Ki will need to be added in order to form blah, 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 blah. Well, that's a different question. That's why I'll have to do a mole conversion. Or the other type of question they could ask is how many grams of lead iodide would be formed because it's a solid, I can do that. How many grams of lead iodide can be formed from adding 15 milliliters of this substance, and the process stays the same. Okay. Notice that the big change in these problems is going to be the use of molarity to solve the problem. Okay. Let's see one more just like it. What volume in milliliters of 0.25 molar sodium sulfate solution is needed to precipitate all the barium as barium sulfate from 12.5 milliliters of 0.15 barium nitrate solution? Process doesn't change. Start by writing down your formula. Remember, you get 1 point just for writing down the formula, so it doesn't hurt you to do that. Plug in the information for what you know. I know barium nitrate, so it's a 0.15 molarity solution, and I have 0.0125 liters. Cross multiply. 0.0125 times 0.15 0.001875. And this is moles of barium nitrate. Okay. The question asked about the sodium sulfate. So I set up my mole ratio, and 1 barium nitrate in my chemical reaction is equal to 1 sodium sulfate. So that makes that math really easy. Don't even need to pull out my calculator for that one. Look at that. Plug it back into my molarity formula. Solve for my volume. Divide my number by 0.25, and I get 0.0075 liters. It asks for milliliters, so this time I remember to multiply by 1,000. Move the decimal place 1, 2, 3, which is 7.5 milliliters of solution. Now, does this make sense that I only added 7.5 milliliters? Yeah, I only started with 12.5 of this one, and you can see that there's a big difference between the two concentrations. So it makes sense that I'm using something so much smaller. And that's how to solve solution stoichiometry problems. Like they said, the only twist they could possibly give you is to really ask you how many grams of the product could be formed, and that's easy once you've found the number of moles. The key to this, notice, is we started with molarity. Molarity is going to give us the moles, which will allow us to use the mole ratio, which will allow us to go to wherever we're going to go from that point on. And that's solution stoichiometry.